that are done strictly by enforcing the referential integrity of the underlying data structures. There turn out to be about 29 rel bars to handle all of the other things that are there. Now, you're seeing only, again, very small snippets of what can go in there. So, using referential integrity to enforce semantic constraints, like I say, it's interesting. I like it because, again, I have to write very little code to make all of that happen. However, not everything can be done this way. There are certain kinds of things that you really want to detect that really sort of need to be looked at. So sometimes we do the semantic analysis by query. And this is a case of finding isolated states. It's quite possible to find a state machine that has no incoming transitions and no outgoing transitions. And if you do so, any action that you have in that state will never be executed. It's in essence the state machine equivalent of dead code. And Pika decides that that's an error. Right? So the question is, how do you find all of those things? And so this is actually the code out of Pika that does that. So the strategy here is to say, well, I want to find all the states that have no incoming transitions, and I want to find all the states that have no outgoing transitions. And if you think about it, the intersection of those two sets must be the ones that have none, and those are the ones that we want to declare an error. And so that's what this little query does. Relational semi-minus is a relational operator that roughly tells you which tuples in a relation are somehow not related to another one. So here in this first line, we're looking for all of those states where their state name doesn't somehow show up as a new state. And the new state attribute in this particular transition relation is the one that points to the destination of the transition. So if you're somehow not a destination of transition, it means you have no incoming transitions. By the same token, the state name in this relation is the source of the transition. And so roughly speaking, from a semi-minus, we're looking for all those tuples in state that somehow don't show up as the source of a transition. And if you're not the source of the transition, then you don't have any outgoing states. And then it's a simple matter of simply taking the intersection of those two. And at that point in time, you have a set that you know is in error. Relation for each does what you would expect from a Tcl thing. It iterates through a set, one tuple at a time. Relation assign does much what LAssign does. It takes a singleton relation and assigns it into ordinary Tcl variables that you can then use in something that we just call the report the error. And it says, well, on this line, there's a state that I didn't have any incoming or outgoing transition. Turns out there are about 18 of these queries within Pika that, again, look at these various aspects by going through and determining whether or not you have made what, again, are perfectly syntactically valid definitions, but they don't make a lot of sense. I want to touch a little bit about what I call friends of Pika, and this sort of falls under the category of if you've got it, you can use it. But really what it falls under the category of is that often when you set out on a project, it's really hard to know exactly where you're going to end up. And it's nice to have a little flexibility in there somewhere. When I certainly started building Pika, I didn't quite know where all of this other support might lie. And these are three examples of where things got to be very useful. One of them is a program called Pika Explorer, and it allows you to view the state transition matrix. When we ball all of this stuff up and push it down into our little tiny embedded systems, we don't push any strings down there. Strings are really not allowed. We don't have space to store strings down there. Everything is encoded in small integer values. Well, that's fine. So if you're sitting there debugging and you say, well, gee, what's going to happen next? I just caught this state transition, and I'm in state 4, and I'm about to receive event 3, and now I'm going to go to state 7. I wonder what that means. Because everything you're going to see down in the target is, of course, going to be numeric. So the idea here is that Pika, because Tcl-RAL will serialize the relation variables out there, we can save that as a populated schema, pull it up in another program, and what this thing does is then lay out in a nice little form what the states are, what the events are, and gives both the name of the state and the numerical encoding it has, so that you can sit to the side and go, oh yes, well I'm in state 4, that's really, I'm washing and things of that sort. Another one that's very useful is Pick it to doc. State machines, of course, are directed graphs. And sometimes you really want to know exactly what the directed graph looks like. I usually design the state machines graphically in the first place, but of course we all know that things can kind of tend to drift over time in development, and sometimes you like to know exactly what that graph looks like. For those of you that may not be familiar, DOC is a beautiful directed graph layout program written by the brilliant people at AT&T Bell Labs. You can obtain it from, it's part of a GraphViz packet that's now open source, and you can go to graphviz.org. And really what Pick It to Doc does is it looks at all the transition information you specified, and then simply spits out a file that DOC then consumes, and DOC will lay it out and produce it in a variety of different graphical formats. It turns out to be very useful. It also can include the code or comments in the state labeling, and it also can denote which is the initial state and a few other nice graphical entities. A third one is a package for tracing the mechanisms. Our execution architecture can conditionally compile in state machine tracing. Now, since by definition we focused all of the execution sequencing to this one body of code, we can actually look at the transitions and state transitions going on throughout the entire application by simply compiling it in. But again, down in the target, everything's numbers. And you can go in and pull all the numbers out, but honestly, looking at 17 transitions at 30, it doesn't make a lot of sense. So what this is a package that will take all of that stuff that Pika saved, take all the numbers that come from the raw trace information, and make it into human readable string of strings that show you each instance and how it transitions and things of that sort. Therefore, you can get a chronological list of the state transitions, and this is extraordinarily valuable in trying to figure out what in the world is going on in these systems. So, is there a moral to our story? Well, yeah, of course, there's a moral to the story. So Pika is a language processing program that, if you really look at the internals, literally looks a lot like a database application. I mean, the use of relational structures provides a very flexible way and powerful way to structure the internals of the program. The Pika language itself is really simply convenient syntax for populating these relational data structures. And the nice thing, of course, is there's in relational data structures, you have a single consistent algebra. You don't really have to write a bunch of access layers that enforces all the referential integrity constraints and operates a set at a time. So a lot of looping constructs just go away. This is all set-based operation. The nice thing is that Tcl has a lot of different ways to deal with relational data. If if the back-end database management aspect is an important part of the application, then again, things like SQLite or connecting to the bigger databases makes an awful lot of sense. If it's not so important, you can get the benefits of doing the relational algebra using Tcl, and if simply serializing data streams is sufficient for that application, then that works very nicely. You don't have to learn any SQL, and you can do all the normal things that you're used to doing in Tcl. Last year, Richard gave us a talk on SQLite, and during that talk, he said something to the effect that SQLite wasn't trying to compete with Oracle, it was trying to compete with fopen, which I thought was very witty. The truth is that Tcl is not trying to compete with SQLite. What it's really trying to compete with are arrays of nested lists, of nested dictionaries, and other sort of ad hoc data structures for which you have to write all these access layers that, come on, let's face it, guys, probably don't get the attention that they really need in your programs. The bottom line is, you'll just be happy with yourself later if you encode the rules of your application in data first, and then worry about the processing that has to go on top of them. It's not, a lot of people will say, well, I don't really need relational data structures because I'm not going to do any ad hoc queries or things of that sort. But the truth is, a given program won't. But as you can see, the friends of Pika do all kinds of ad hoc queries on those data structures. And you sometimes can't, at least my vision is not so good at the beginning that I want to give away that flexibility when I know further down the road I may well need some additional support for the development. Lastly, all of this is available under some open source projects licensed in the same license as Tickle. This is, if you go over here, you'll find that it talks about tools for the Cortex-M3. That's fine. They're a little more general than that. There is a lot of Cortex-M3 specific microcontroller stuff over there. This particular stuff is actually quite general. In fact, the example that I have in the paper, I have running here on this little machine, if anybody really wants to see it. I'm going to spare you the demo because I haven't been sacrificing to the demo gods, and I know they would make something go wrong. So, I'm not going to even attempt that. But if anyone wants to see it afterwards, but the whole execution architecture will run on a POSIX machine, as well as the microcontrollers. And of course, I use that for simulation purposes. A little bit easier to do it that way. Are there any questions? All right, I'll stun you into silence, and everyone's hypoglycemic and ready for lunch. Okay, thank you very much.
Thanks, Tom, for coming. Actually, done a little bit early. I think you're talking a little short. But lunch is 3 hours early too, so it all works out. Lunch is in the atrium area. The sandwiches are scattered randomly. If you don't like the one that you see there, try the next one over. They have Italians and chicken sandwiches.
I bet Steve's.
Usually nice for lunch, doesn't it?